It is known to the locals as the Sea of Death. The Taklamakan Desert in the Xinjiang region is a brutal, unforgiving, and shifting wasteland of massive sand dunes and blistering lethal heat. Spanning over 300,000 square kilometers, it is one of the largest shifting sand deserts on the entire planet. For millennia, this treacherous landscape has been an absolute barrier to human progress, a place where extreme weather and lack of water ensure that nothing survives. But the modern engine of human ambition and geopolitical strategy sees no barriers. China requires a continuous, high-speed logistical lifeline to connect its remote, resource-rich frontiers with the rest of its massive economy. They needed a railway, but to build it, they could not go around the desert. The solution, driven by staggering economic power and raw engineering arrogance, was to declare an all-out war on the sand. They decided to split this 2,700-kilometer dead zone entirely in half. Welcome to the construction site of the Taklamakan Desert Railway Loop, a $40 billion mega-project that is completely rewriting the rules of civil engineering. To understand the sheer insanity of building a massive railway through the heart of the Sea of Death, you have to understand that construction does not begin with steel and concrete. It begins with a brutal mechanical war against the shifting earth. The first obstacle is not solid rock, but mountains of loose sand. The dunes here are not static. They are massive, creeping giants that can reach heights of over 100 feet, constantly migrating and burying everything in their path. To clear a path for the tracks, engineers unleash an armada of heavy machinery. Fleets of massive, heavy-duty crawler bulldozers plow relentlessly into the towering sand dunes. The environment is absolute hell. The ambient temperature regularly exceeds 120 degrees Fahrenheit, creating a violent heat haze that distorts the horizon. The massive diesel engines of the bulldozers scream in agony, constantly overheating in the blazing desert sun. The operators, sealed inside air-conditioned cabs, are essentially driving blind as the heavy steel blades violently shear off the tops of the dunes, sending blinding, choking clouds of yellow dust into the air. The sand fights back constantly. It is fluid, slipping and collapsing under the massive weight of the steel tracks, threatening to swallow the heavy machines entirely. Slowly, violently, million by million cubic yards of sand are forcibly relocated, carving a massive, shallow trench through the desolate landscape. But leveling the sand is a completely useless endeavor if the relentless desert wind just blows it right back over the tracks the next day. To physically stop the desert from burying the $40 billion railway, engineers deploy a mind-boggling manual defense system that relies on sheer human scale rather than machines. In the midst of blinding, skin-shredding sandstorms, an army of tens of thousands of workers is deployed directly into the scorching dunes. They are tasked with constructing the sand grid fortress. Using nothing but specialized shovels and raw physical endurance, these workers manually bury millions of square meters of dry reed and straw deep into the sand, forming a massive, interlocking checkerboard pattern that stretches for miles on either side of the tracks. This creates a colossal, artificial root system. The friction caused by the exposed straw breaks the kinetic energy of the howling desert winds, locking the shifting sands firmly in place. Over the course of years, a massive artificial green corridor of drought-resistant vegetation is planted directly into these grids, transforming the dead sand into a living structural shield. However, there are areas of the Taklamakan where the dunes are simply too massive and aggressive to be stopped by vegetation. Where the sand cannot be controlled, the engineers refuse to fight it. Instead, they build right over it. The project transitions from raw earth-moving to heavy vertical engineering. Massive, crawling pile drivers are brought to the edge of the deepest sand seas. These towering machines hoist colossal, hollow steel casings high into the hot, distorted air and violently slam them hundreds of feet deep through the loose, unstable desert floor until they finally hit solid bedrock. The casings are then pumped full of heavily reinforced, specialized, quick-curing concrete. These massive subterranean pillars form the foundation for miles of elevated viaducts. Colossal, specialized bridge-laying cranes slowly crawl along the newly built pillars, lifting massive, prefabricated concrete bridge spans, each weighing hundreds of tons, and locking them into place above the dunes. The engineering logic is brilliant. By elevating the railway, the relentless, shifting sands can blow harmlessly underneath the tracks without ever burying the steel. Once the path is secured, either by the living green corridors or the elevated concrete viaducts, the true mechanical stars of the project arrive. These are the track-laying leviathans. Unlike traditional railway construction, where small crews manually bolt tracks together, This massive project utilizes colossal, automated track-laying machines that operate like crawling factories. These massive steel beasts move relentlessly across the scorching, leveled earth. At the front of the machine, heavy mechanical arms automatically drop massive, reinforced concrete sleepers into precise, laser-aligned positions on the crushed gravel ballast. Simultaneously, the machine feeds miles of continuous heavy-duty steel rail from specialized transport trains trailing behind it. High-temperature, automated welding robots clamp onto the joints where the massive steel rails meet. They unleash blinding showers of orange sparks, fusing the steel together at extreme temperatures. The heat from the welding mixes with the blowing sand and the smell of burning hydraulic grease, creating an intensely gritty, industrial atmosphere. Because of the extreme temperature fluctuations of the desert, which can drop to freezing at night and boil during the day, the steel rails must be tensioned perfectly to prevent them from buckling or snapping under thermal expansion.
Yeah, we made it! Great job, everyone!
Set per blow decreasing. We've hit refusal condition, confirmed stoppage.
Lower the trimming. Keep it steady now.
All right, opening the hopper, watch the flow rate.
Heave. All right, pull it out. It's coming loose now. Bring it down 5 centimeters. Hold the line tight. Looks good, keep it coming. Keep the tension on that line. All right, easy now, bring it down. We're almost seated.
The drift depth here is significant. Reading 4.2 meters on the north side. Noted. Check the western face next. Check the expansion joint stress reading here.
Stress levels are slightly elevated, but within tolerance. I'll log it.
Watch the alignment on the left. Okay, bringing it down slowly. Hold it there, secure the base. We did it! 1,000 kilometers completed! Yes. Great work, everyone.
Keep pulling, it's almost through.
Watch the tension on that drum.
All right, secure it here.
Easy now, bring it down slow. Almost there, watch your hands. All right, set it down. We are done here.
It's done!
We made it! We finally made it!
This is the final acceptance line right here. The results are confirmed.
Yes, they are. I'll sign off on it now.
The surface looks good here, minimal abrasion. What's the reading on the alignment?
Within tolerance, actually better than expected after that storm.
The logistical nightmare of keeping this massive operation running in the middle of a dead zone is staggering. Every single drop of water, every gallon of diesel fuel, every piece of steel, and every meal for the workers must be transported hundreds of miles into the deep desert. There are no nearby supply towns. The construction sites operate as massive, moving cities, completely isolated from the rest of the world, fighting a daily battle against dehydration, heat stroke, and mechanical failure caused by the fine, abrasive sand destroying the engine intakes of the heavy machinery. When the final rail is welded into place, the visual reality of what China has achieved is absolutely staggering. The ultimate test arrives on a day when the desert unleashes its fury. A violent sandstorm, a massive wall of dark, choking dust rolls across the landscape, completely blotting out the sun. But slicing directly through the heart of the storm, a massive high-speed freight train tears across the newly laid steel. The heavy aerodynamic nose of the locomotive shatters the wall of dust, its massive wheels gripping the precision-engineered tracks perfectly. The $40 billion mega railway holds firm. The living green corridors deflect the blowing sand, and the elevated viaducts allow the dunes to shift harmlessly below. From the perspective of a high-altitude drone pulling back into the clouds, the scale is awe-inspiring. A perfect, continuous, 2,700-kilometer steel spine now encircles the deadliest desert on the planet. It is not just a triumph of laying track. It is the ultimate manifestation of human endurance and heavy engineering dominance over extreme hostile nature. China didn't just build a railway. They violently split the Sea of Death in half, turning a barren, impassable wasteland into a multi-billion-dollar artery of global commerce.